Okay, so let's take a moment to compare the two approaches that we've gone over, either setting the gradient equal to 0 or doing gradient descent. Well, in the case of minimizing residual sum of squares, we showed that both were fairly straightforward to do. But in a lot of the machine learning methods that we're interested in, taking the gradient and setting it equal to 0, well, there's just no closed form solution to that problem. So often we have to turn to methods like gradient descent. And likewise, as we're going to see in the next module, where we turn to having lots of different inputs, lots of different features in our regression, even though there might be a closed form solution to setting the gradient equal to 0, sometimes in practice it can be much more efficient computationally to implement the gradient descent approach. And finally, one thing that I should mention about the gradient descent approach is the fact that in that case, we had to choose a step size and a convergence criteria. Whereas, of course, if we take the gradient and are able to set it equal to 0, we don't have to make any of those choices. So that is a downside to the gradient descent approach, is having to specify these parameters of the algorithm. But sometimes we're relying on these types of optimization algorithms to solve our optimization objective.